So here they are, and this actually looks like a process meter. They call it a signal generator, but I think it's essentially a process meter. I think that's what it is. Anyway, we'll power it up and take a look. And here's this 2-in-1 oscilloscope, and yeah, it's got a ZIF socket transistor tester. We'll see what that's like. And we've got the mini coaxes on here, not a regular BNC. So right off the bat, that makes it much less, like it's equivalent to like one of those DSO nano things in terms of like interface. But it is small. But yeah, we've seen other FNIRSI ones with the BNCs on them, which are more useful. But this is like a pocket thing. But why you need a transistor tester in a pocket thing like that? No, jack of all trades, master of none. I don't have to power it up to know that. Why do you want a transistor tester? Oh, okay, it looks like you get a lot of stuff, but I'm very confused. What is this? This is a regular probe. No. I'll tell you what though, I do like the funky pattern they've got inside there. Oh, I missed it. We've got a little adapter in here. Okay, cool bananas. All right, it makes sense to use to supply a standard probe. But then the problem is that that's going to be like, you could easily break that off. Easily. I don't see that lasting long at all on a bench, especially in a portable thing that you're like throwing around, and the weight of the cable, if you snag it, you're just going to like break that off. So no. Actually, I don't see an easy way to take that apart. I guess the case might just pry open. So anyway, let's power it on first. Here we go. Oh, there we go. And firmware 1.0, was it? Hello? Might not be charged. I heard some relays click. Yeah, no, I'm going to have to charge it up, I think. So let's take apart this signal generator, in quote marks, but I reckon this is a process meter. Input, less than 30 volts. In, 24 volts. What? Okay, well, let's peel that off. Let's turn it on before we take it apart. I know that's terrible, Muriel, but there we go. Or is that the on-off there? Oh, there we go. Look at that. Geez, there's a lot on there. There you go. We've got our current output and our current input. So let's actually just loop it. So if I just loop the output through to the input here, and let's set in out. Okay, how do we do it? Oh, output. I can move the digits there. What's going on? This is not intuitive. Oh, out. Oh, on. Okay, it's got a little run LED up there. Oh, geez, you got to read the manual. Output. There we go. Basic. The range. Program. Geez, it's calibration. Okay, so you can calibrate it by putting in values. Okay, do you calibrate it at 6, 12, and 18 milliamps? So yeah, this is like a 4 to 20 milliamp, like, generator, like process meter type thing. So basic, actual protection, 0 to 24 volts. Yeah, 4 to 20 milliamps. There you go. 20, 0 to 10, or user. Can generate frequency, can generate pulse, PWM, speed. That's pretty useful stuff. Use 24 volts. Oh, the interface. Can you actually hook it up to the USB? That'd be, maybe it's got PC control or something like that. Out time, graph. There you go. Output auto zoom and stuff. So, geez, it's fascinatingly complex, isn't it? Okay, I'm able to shift this waveform by just pressing the in button. I don't know, is that button doubling as current input 25? Oh, okay, that's weird. Okay, so that's different. Right, current input milliamps, current input 20 minus 25. What? I'm not getting this. What is a cuttant? Is this some industry term that I'm not aware of? So, yeah, RTFM. Right, so what it can do, active current output, 0 to 24 milliamps. Yeah, this is, for 4 to 20 milliamp current loop. This is all process meter stuff, 0.1% plus 0.005. That's, a decent spec for, a portable process meter like this. A voltage input, 0 to 30 volts, and current input, 24 volt loop. Yep, max voltage output, so it can just generate the 0.1% currents and voltages up to 24 milliamps and 30 volts by the looks of it. So they've got two input ports here, which can be switched. Yeah, okay. I'm gonna. All I want to do is output a current and measure it and feed it back right up its own clacker. Okay, it was totally non-obvious that you press function and then the out or function in to get to the input or output menu, but that's what it is. Okay, so I'm going to try and get a milliamp output, 0 to 24 milliamps. Yep, loop voltage, that's the compliance voltage. 12 volts or 24 volts, that's fine, we don't care. There we go, so it looks like you press that and it changes the range. So 1 microamp resolution, that'd be groovy. Over current, really? How do I adjust it? That turns the output off and on, but I don't know how to adjust the digits. Surely I should just, like it's selected, surely I should just be able to press up and down to adjust the output current. Well, I got rid of that graph rubbish to make it look like the output here, and that's actually a really nice display. I like that, but it was so hard. Like you got to go into the settings here, and then you've got to go into in-ac op, and then you've got to press that to select between char and curve, and that's what disabled. It was on curve before, and that's what was enabling the graph screen. That's so convoluted. I still haven't figured out how to adjust the current. There's got to be a way. Like that digit's selected. Why can't that just go up? I don't understand. Well, I turned it off and on again, and sure enough, maybe it was in some lock mode or something like that. Anyway, there you go. So we can generate currents like that, and that's nice. I like that interface, but okay, let's go output. There we go. And it measures current input because I'm feeding it back up its clacker there, 1.1. Perfect. So it reads. Spot on. Can we change the input range? Like, no, we can't change that range to match the resolution, but yeah, neat, huh? So there you go, that's 1.1 milliamps on my Keysight jobby here. It's, is that within spec? I think probably. And there's 10 milliamps, so that's pretty bang on, isn't it? Wow, happy with that. Can't complain. Let's go up to our maximum. 24, yep, and you can set limits so that you don't like accidentally go over and blow up your sensor, your widget or whatever. So yeah, that seems pretty accurate on current. Of course, when you get down to the bottom of the range, although we can change our range there, I don't know what 400 watt range. There's no milliamps, like it can't go that high anyway, so I'm not sure what the 500 watt. I don't get that. Current output is 300 watts. As in watts, watt, and we're getting 6 milliamps. I don't get it. There you go. Okay. If you try and generate 10 microamps, right, obviously there's going to be some error down there. But anyway, that is useful. A little portable process meter for generating currents for testing and calibrating sensors and stuff like that. That's what process meters do, and we can generate a voltage as well. I really don't like the way you have to switch to like the voltage output. You've got to go like into the function, and then you've got to like select it there and then go back out. So that's your milliamps, and you can go in. Okay, it's obvious once you know, but you know, anyway. So now we've got voltage output, so we can get 1 millivolt there, but obviously it's down in the noise, 0.1 volts. Oh, I'm going to turn the output on. Why is that not outputting? It's not outputting. 0.9, 0.6 volts. I've got 0.9 volts. What? Okay, now it's suddenly decided to work when I went up to 10, but it wasn't working before. 9, 8, well, that's out. I mean, 7.9 volts? 7.9, and I've got 8.000? Is this thing not calibrated? That's like way out of spec. 3.8, that's a fail. And if I go down to 1 volt, there you go. That's why it was giving me 0.7, because it just seems way out of spec. This is factory out of the box. What the? And well, I don't think I'm doing anything wrong there. I mean, voltage output, 1 volt. I should get 1 volt within, you know, the 0.1% tolerance spec or whatever it is. And the manual doesn't help much, by the way. There's not much in it. It's got a spec and it's got what things do, but like not how to like, anyway, you know, it does have some potentially good functionality in it, but yeah, I don't know, because like it's got for voltage and current and frequency and stuff, like you can do, you can get out of there, and you can do like a programmed output, so it looks like you can do like cycles up and down and stuff like that. So not sure at what repetition rate, but you know, you can cycle things and stuff, and you can do presets, and as I said, you can set like range limits so you don't accidentally damage a sensor that you're trying to power and calibrate, because that's the idea of a process calibrator, is that you calibrate all of your, you know, 4 to 20 milliamp current devices and voltage devices, for example, like a lot of industrial stuff. If you're not into the industrial stuff, it might give, you know, 0 to 10 volts is like a, you know, hugely common standard for like voltage output of sensors and stuff like that. And these are process meters are designed to go out and measure, like a process calibrator, really, designed to go out and, you know, calibrate and set up your sensors out in the field. But yeah, I mean, if I can't trust that that's 1.0 volts, then I don't know. I don't know what's going on. Anyway, let's crack it apart. It has potential, but oh my goodness, the user interface, and well, I don't know what's going on with the voltage. And there you have it. Wow, there's not much in there. We've got a 3000 milliamp hour battery over here, and well, that's all she wrote. On the top there, I'll put some high-res photos over on the EEVblog Flickr account, and you can analyze that to your heart's content, but there's got to be more on the bottom. So this is just your output stuff. I don't know, you know, because the whole point of these is that you have, you know, a decent voltage reference in there, and then a decent, you know, then you implement a decent current reference and stuff, and how that's adjustable. And these are like incredibly useful. Could be like a very nice platform to do like a hacked process meter or something, because I don't know how much this costs. Let me check the price. Are you kidding me? This thing's currently on special for $50. It's like half price. Unbelievable. And by the way, yes, you do get all the probes as well. You get 4 different color probes and a little USB chargery thing in there, but geez, for $50. All right, but I do expect it to at least give me the voltage output that it says. So I don't know. Maybe I'm using it wrong. Maybe something's happening there, but anyway, I can't imagine what, because it works at 10 and then I lower it and it doesn't work. Okay, so that's all nice. I like how it's implemented, and the case is all very nice and everything else. So yeah, there's our screen, and there you go. Geez, there's not much in it at all, is there? Don't know what processor that is. It, oh geez. Hey, what? I can't read that on the screen. Anyway, assuming you can get it, probably, but geez. Okay, so it's just micro, an LCD, a couple of buttons, and there you go. For those playing along at home, like this looks like just the power supply section, so this looks like all the voltage and current generation stuff. Wow, okay, is there an ADC in there as well? Once again, I'm not going to go into details. High-res photos on the EEVblog Flickr account. But that's a real simple interface, and that's how they can sell. I'm still amazed they can sell this for $50 US. I mean, well, that's half price. Normally, even at $99. Geez, if it works as a process meter as claimed, unfortunately, well, it'd be fantastic, but unfortunately, I don't know. I've got issues. Further testing required. It's all I can do on the mailbag, but geez, it's an interesting device. Okay, it's kind of charged now. MOS test. MOS test oscilloscope. Okay. What? Oh, okay. Right, as in MOSFET test, as in transistor test. Okay. So you can do transistor tester or an oscilloscope. Like, why even try to combine them? No. Just, anyway, let's go into our transistor tester. There you go. No, it's just a transistor tester that you can get with those little, open source, couple of $5 cheapy things, right? It's got that integrated in because they think it's useful. If you want that functionality, like, just get one of these. Like, you don't need to build it into a pocket oscilloscope and then go, like, no, you just, like, Okay, this is an MPSA 42. How do I get it? Test. There you go. There you go. Yep. Okay. BJT, NPN. I believe that is correct for an MPSA 42. You can go look it up. I mean, really, like, that's wonderful, but why do you want to have it in your portable oscilloscope? I don't know. Just make a good portable oscilloscope and then just, leave that to, like, the other ones that are, more refined, proper tool for the job. Yeah, anyway, let's go to the, how do we go to the menu? Oh, there you go. Okay, function, explain what's going on, continuity, PWM, Zener diode. Okay, so it looks, okay, this is pretty comprehensive, I've got to admit, right? But, like, no, just make this as, like, a dedicated instrument and then, like, put all your effort into making that good. Explain about oh, I can't go backwards, I can only go forwards. Okay, startup logo, on or off. Like, why do you need, like, continuity test? Who's going to use this for continuity test? Seriously, I mean, no. So can I go back? I don't think I can go back. I think I just got to turn it off and on again. There you go, oscilloscope. Okay, we're in. Okay, geez, that's updating pretty quick. So anyway, we do have a PWM generator and a mysterious input, 0 to 16 volts. Don't know. Plug in our, dodgy probe. Oh, God, that's just going to fall off. Oh, no, no. Like, and I'm not going to use the manual. I'm just going to, like, this is all the interface that we've got, right? And, okay, stop run. Okay, so you don't even know that stop run. Test hold, I guess that makes sense, right? Maybe. Up and down. It's not even moving our waveform. Okay, right, so we're selecting our thing. So, auto. So we've got to use this button to go through duty cycle, PWM. Okay, so I presume that's our output. 1 kilohertz, 50% duty cycle. And then, okay, so now we've selected this. So you have to cycle through. And so you got the one button interface to cycle through, and that moves our waveform. Oh, no. And, there's an infrared. Infrared, why? Why? Does it do infrared generation or testing or something? Is it another function that they're trying to throw into this kitchen sink? Anyway, yeah, look, okay, so now we can change our range, 1 volt, 2 volts. So it'll go down to, it's really hard to read that blue, 10 millivolts per division. And then we can go to our, we can't change our times 1 times 10 probe. That's probably in the setup menu somewhere. Okay, and then we can change our time base. And then we can change our coupling. Okay, no worries. And then we've got a menu. Where does the menu go? Please press OK to start. I held down that and it went into some calibration. Start calibration or hold down auto to cancel this calibration. Do I dare do it? It's going through calibration mode. I do have the probes connected. Okay. All right. So how do I set my PWM output? Okay, so let's plug in PWM. There you go. Let's see if we can get our auto. Our auto detect. Yeah, there we go. Auto detect actually works. So, so we've set our 1 kilohertz up there, and it's measuring 1 kilohertz here. And but geez, look, I don't know why you'd have one of these. There's better. Like, even the other ones that FNIRSI do, the other pocket oscilloscopes are better than this one. It's trying to be a jack of all trades, and it's just it's so fiddly. I don't know why you'd want one, really, and that's just not going to last. Then there you go, didn't have it plugged in all the way. But that's just going to break right off. Oh my goodness. Yeah, I suspected so. Infrared remote control decoding. While the tester is waiting to test, aim at the IR mark of the panel. Okay, I might see if I can get into that. But once again, like, jack of all trades, you know. Zener diode testing up to 21 volts. That's actually rather useful. Yeah, okay. DS-18B20. Turns out that's a one-wire digital thermometer, so you plug it in there and you can measure temperature. Okay. DHT11. I think I've heard of that one. I think that's another temperature sensor. I don't get it. Where's the optical? Is that not in there yet? Is the optical not enabled yet? I mean, surely I would have expected it to find it in here rather than the oscilloscope. This is like part of the advanced function thing it can do. So I don't know, maybe they haven't added it. So they advertise this as a transistor tester, but it's not. It's basically it's one of these M-tester things, just like this, and like everyone's copying this. I think it was open sourced by somebody or something, wasn't it? I don't know. Can't remember the details, but it's basically there it is, the M-tester thing, and it's a full LCR meter, and it does all sorts of things. So I reckon this does more than just transistors. And sure enough, yep, measures a capacitor. No worries, 479. Let's move it over one, see if it does that again. And it should. Yep, well, 474. There you go, 1 and 3, and it automatically determines on which pins you put it. And cathode and anode, that's for your LEDs and your Zener testing and stuff like that. So I actually consider this more of like a glorified M-tester, you know, like a fancy-pantsy version of one of these, which can do some additional things, as you saw in the advanced function menu, with like a little oscilloscope tacked on. So I think that's what they're doing there, and maybe they'll release software, or maybe I haven't found it, for the infrared testing and stuff like that. So it's a useful bit of kit for $50. I mean, but yeah, no, you would not be buying this as a digital scope. It's too difficult to use. And I don't know, leave it in the comments down below. Are there better, I do believe there are, like, better, more advanced, fancy-pantsy versions of this. And yeah, this one is just, I consider it fancy-pantsy LCR version of this, with the ability to view some waveforms and generate some PWM signals and do some other stuff. So it's an interesting bit of kit, but they advertise it as a DSO and transistor tester. I don't know. It's a weird mix. So you do get the probe and lots of little attachment bits, and you get some little easy hook type things to go in there and do components. So, it's kind of useful, but yeah, you wouldn't be buying this as an oscilloscope. Just don't go there. Anyway, that will be a nice addition. I probably use this thing actually instead of this, because it's kind of like, it's flapping around in the breeze, and you got to find a 9-volt battery, which you never have. Spend more time looking for the battery. And this thing in the future, yeah, it's just for a simple LCR and transistor tester. It does the job. And if you can get it for $50, like it's on special at the moment, it's actually pretty good value. I mean, you can't complain. There you go. You can just light up LEDs there, and I haven't even gone into the actual tester yet. So we can actually put that LED over to here, and we can actually run a test. Oh, blinkety blink, blinkety blink, and it tells us our forward voltage drop. It doesn't say at what, and the capacitance as well. It doesn't say at what test current though. Okay, I've got a 20 volt Zener diode in there, and it's reading 18.9 volts, so that depends on the test current, of course. So, yeah, it's not that accurate. 18.9 volts, I'm reading 20.5, so, yeah, nah. It's that's like, I got to go through it, it just reads it live like that. So yeah, if I take that out, there you go. It's 21 volts max compliant voltage, but yeah, that's not accurate at all. No, it's disappointing. Okay, I got a 13 volt Zener diode in there, marked nominal, 13 volts. And, well, 12.7, 12.5, you know, that's okay. But, like, I'd expect that to be, like, a bit better than that. So, yeah, that is disappointing. So anyway, this thing's on sale for around 40 US bucks, which I don't know why you'd want it though. I don't know why you'd want, like, mate, like, it's just got, it does a couple of things that are useful, and like the oscilloscope is like, gee, no, like there's better. No, this is a great example of the right tool for the job. They've just made this and thrown in the kitchen sink at it for a ridiculously low price point. Normally it's not, you know, 40 odd bucks or whatever. I think it's normally 70 or something, but like they're throwing everything at it, and I don't know what to think about this. Okay, let's crack this 40 buck wonder open. It looks like there's no screws on it, so it looks like it's just gonna, this is just gonna lift up all around here. There you have it, 1500 milliamp hour battery pack just stuck down there. It's got some protection on it. And once again, I'll put a high-res photo on the EEVblog Flickr account, linked down below, so you can go to your heart's content. But yeah, it's like, got a relay in there, thank you very much. Yeah, like it's remarkable how they can, you know, design, build, and sell this, like on the store for like 40 bucks delivered here to Australia. It's just absolutely insane. So I know it's like next to impossible to criticize something like this for, you know, the value for money in there, like for 40 odd bucks delivered is nuts. But yeah, it's a poor oscilloscope. It really is, and you can get the those testers for cheaper elsewhere. So, you know, in many different form factors and stuff. So yeah, I don't know what to think about this. As I said, you certainly wouldn't buy it for the oscilloscope, but you know, for 40 bucks delivered, you can't knock it. It's absolutely incredible value. Whether or not it's useful to you, I don't know. Leave it in the comments down below, and yeah, let us know what you think. Catch you next time.